Today I would like to draw your attention on energy management in the port, because it's becoming more and more important to let's say have a focus on that. It's also some kind of data integration, and it's also related to IT. So I would like to tell you a little bit about that. Also, we had in our port integration day, we had a full presentation about this issue. It's like a project report from our terminal in Tallinn. This was former Muuga port. It was acquired 2 years ago from HHLA International, and it's a mid-size multi-purpose terminal with containers, ro-ro, and also general cargo. And there we have a project ongoing about energy management. Yesterday in our presentation we had let's say a previous introduction about SCADA systems with a presentation about iconics, which we cannot repeat here. But the idea of this project was to create a digital twin of a port. A digital twin is a let's say wording from SCADA systems that you show a technical copy of an asset, and why not do this for the entire port? So the idea is to establish a technical control room and then make sensor integration. Use cases could be heating, air condition, light control, facility management, but also energy management in terms of consumption and control of consumers and maybe also producers. You could do IT network surveillance. You can include fire detection, sensor alarms, intrusion control, security. There's let's say only the limit of fantasy to tell you what you can do or what you cannot do. Similar like Manuel says, you can do everything with anything. So the next question, why should we pursue energy management in the port? It is clear that this is our contribution to climate change. We have to think about, but it's also cost optimization for the ports, and it also creates new business. It's let's say very much in fashion is sustainability everywhere in the port. We at HPC have a lot of projects in that direction. It's about energy transition. We want to go away from the old traditional way of using energy. It's also, of course, electrification versus diesel. We have a lot of electrified equipment. Nobody likes diesel anymore. It's about measure and control energy consumption. But in future, it will also be about generation of energy. It's easy to put photovoltaics on your roofs. At the horizon, we already see the hydrogen technology coming. It's offshore wind parks that we could integrate, and we could also feed or balance energy into the public grid. Also, I would like to draw your attention a little bit on this energy certification ISO 50001 program, which, let's say, HHLA terminals are obliged to follow. I come to the details in a minute. This energy management certification 50001 from 2018, let's say, transforms the way how organizations manage their energy and turn it to a systematic approach with sustaining results and a strategic approach how to manage your energy. It is coming with the plan, do, check, act approach. So this means you have certain phases, and the methodology to go that way represents these ISO 50001 standard. So what you do is you are planning your activities, you are identifying your consumers, you are identifying potentials, how to save energy or to control energy in a different way. Then you do an action plan, you monitor the action plan, and finally you never stop and you continue step by step to get energy management under your control. This is the idea of ISO 50001. I'm sure you find a lot on Wikipedia or on public sources about this ISO 50001 certificate. I think it's worth it to follow up and be informed about that. The energy management project in HHLA TK Estonia, some background information, the local conditions, some targets, and the roadmaps. Just briefly for you, the local conditions are, they have 3 SDS trains, so it's a mid-sized terminal. 2 more gantry trains will be sent from Hamburg to Tallinn in May. So then they have 5, so also 5 big electric consumers. At the moment, they have 6 RTGs, but we are going to purchase another 4, and this will certainly be electric ones. We have 10 warehouses with bulk cargo. Also, within the bulk cargo, there's very sensible cargo like cacao beans or grain or something like that. So we talk about sensible air conditions, humidity, temperature control, and so on. We have 59 light poles and warehouse lighting, and we have non-controlled electric and gas heating. This comes from post-Sovietic times. In former Soviet Union, energy was so cheap that they didn't put any controllers. So nowadays, where energy is getting more and more expensive, is a burden, let's say, to get control about your energy consumption. What else needs to be considered for us, for the HHLA international terminals? That HHLA defines their targets for climate change even more stronger than the European Union. The HHLA terminals are, let's say, obliged to reduce the actual amount of CO2 emissions by at least 50% until 2030. We have to be climate neutral until 2040. So for the terminals of HHLA and for all of us, I suppose there's no time to lose, and energy management is one of the keys to get control about this. If we go to this, that's a plan, do, check, act approach, then TK already finalized their first phase. So the decisions from the first phase, or the findings from the first phase, was we want to implement a monitoring and control system, which came from Iconics, was defined as the technical system to implement that. We want to install the first meters and controllers, which you can see here also in the picture, about 50 as a first start level, let's say, to get control. We want to start measuring consumption and switching, especially in the area of light poles. We also want to change light poles to LED, where it's not done anymore. And in this first phase, we are expecting energy savings already about 10 to 50% in the affected areas. So it was the let's say, in the presentation of Iconics, and they said that already for making energy consumption visible and controllable, you will save 10 to 50% as a first step. How do we implement that? So here you see the map of HHLA TK Estonia already under Iconic screen as a, let's say, development scenario. This means you have to make this software, this control software, or compose it, let's say, not even development, and you install all these different meters and controllers with industrial bus systems along your terminals. You use the existing networks, you use wireless networks, and so on. So you have a controller network over your terminal, which is becoming more dense and dense with adding more controllers. The first phase and the expected savings when we have established the control room is especially, as I said, going to light savings. This means we are going to the warehouses through the outdoor lighting, and we want to save the energy there. We will also save energy with recovery of STS cranes and so on, energy recovery, but first phase is focused on light. As I said, savings in the area 10 to 50%. This means in real numbers, the project price for the first phase was about 70,000 euro. The expected savings are 35 to 40,000 euro per year. So we have a investment return rate lower than 2 years. The next phases, let's say second phase, will be continue to install more meters and controllers. We will also include heating and aircon systems and so on. And we want to control also recovery of energy from the big assets, from STS cranes and RTG cranes. There's an example here, what you see on the right side. If you lift a 25 tons container up to a height of 18 meters, you have 1.27 kilowatt hours of energy, but you can recover parts of this energy when you lower this container again, when the hoist motor of the RTG, for example, in this case, is working as a generator and can inject this or part of this power into the grid again. So this is the effect that we want to see from STS cranes, from RMGs, from RTGs, and the savings in this area can be bigger than 50%. This is the experience from other projects also, depending on where you are. In cold countries, you spend a lot for heating. In hot countries, tropical countries, you spend a lot of air conditioning, which you cannot recover. But in total, you can achieve more than 50% of this energy. For the third phase, we are already prepared to include power generators. Estonia has the special problem that the majority of electric power is generated by oil power plants. So the CO2 factor in Estonia is very bad. This means we don't only have to look for reducing our power, we also have to look for alternative sources for power. So this means photovoltaics, wind power, and hydrogen will play a big role in the future in Estonia. And the Port of Tallinn and also our terminal want to contribute to that technology by taking control and integrate that power sources into our management. Also, we will certainly change to electric tractors and forklifts, as we're doing in other ports already. Hamburg has electrified AGVs, so we are following our mother company a little bit in Hamburg with electrical and battery technology, and also include that into the grid management. Hydrogen fuel cells, engine, and power generators will definitely come in the future. So we see from HHLA TK Estonia, the energy management will certainly and definitely be a business factor in the future. Summary and key takeaways. Energy management is a substantial key to reach the climate goals for the ports. In our changing world, energy management will create new business models also for ports. Think about that for the future. It's a long way to go. It's not, let's say, a short-term period project. You have to start energy management. You have to develop these methodologies and these control systems. Don't stay behind. Prepare yourself in time. This is our recommendation. Thank you very much.